Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, you'll see how to configure a one-to-one static NAT rule with a lab demo. So you can see our lab scenario here. I've got int S1, that's my internal S1 server inside my company on the left. It's using private IP address 10.0.1.10 on the inside, and I need to NAT that to a public IP address so that it can accept incoming connections. The public IP address that I'm going to use on my outside interface on R1 is 203.0.113.3. And we're going to need to test this as well. So that's why I also have the external S1 server that I'm going to use to connect into S1 from there. So let's configure this. So I will jump onto my command line here on R1, where I'm going to do the NAT translation rule. I'll go to global configuration, and it's interface fast 0/0 that is my IP NAT outside interface. And interface fast 1/0 is my IP NAT inside interface. So whenever there is traffic going between those interfaces that match a NAT rule, the translation will be applied. I need to configure my translation as well. So my command for that is IP NAT, then it's inside source, and I'm doing a static translation from 10.0.1.10, the private address on the inside, to 203.0.113.3, the public address on the outside. And that's the whole configuration done now. Whenever that host sends traffic out, it will be translated to the public IP address. And whenever traffic comes into the public IP address, it will be translated to the private IP address. So let's check that it is working. So first thing I'll do is I'll ping from the host on the inside, going out to the public server on the outside. So let's set up a debug so we can see what's happening. So on external server 1 on the outside, I'm going to do debug IP ICMP. The difference between a show command and a debug command: whenever you enter a show command, it gives you a single point in time output. It shows you what the state was when you hit enter on that show command. When you do a debug, it gets updated in real time. So whenever anything changes, it will show you the output to your command line as and when it's changing. You'll see what I mean in a second. So I've turned on ICMP debugging on external S1, so when ping packets come into it, we should get some information there. Let's go on to internal S1, the host on the inside that we're doing the NAT rule for, and see what actually happens. So I'm going to ping 203.0.113.20, which is external S1 on the outside. I'll hit enter, and then I'll go on to external S1, and you can see there is the debugs coming in. Actually, to show you debug better, let's do an extended ping. It's IP, target IP address is 203.0.113.20, and let's go for a repeat count of 50 so you can see the debug happening. And I'll just hit enter for everything else and jump over there, and you can see that the output is updating every time that a ping packet is coming in. Okay, so let's look at the output here, and I can see that the echo reply was sent back from the external server to the internal server. The source address used was the external server's IP address, 203.0.113.10, and the destination address is 203.0.113.3. So I can see that my NAT rule is working. The actual IP address on the host, if I have a look at that with a show IP interface brief, this is actually a router I'm using here to emulate the server, and its IP address is 10.0.1.10. So that's the IP address configured on that actual host operating system. But when it sends traffic out, that 10.0.1.10 address is being translated to 203.0.113.3 by the NAT rule on the router. Okay, so it's working fine for outbound traffic. Let's just check that inbound traffic is working as well. So from the server on the outside, I will check that I can get to my web server on the inside. So I will telnet to its public IP address, 203.0.113.3, and I'll do that on port 80, because for this example, it's a web server on the inside. So I'll enter 80 for the port number, and I can see that that is open, so it was able to connect. I've already configured the host on the inside to be a web server. Okay, so NAT is working in both directions. It's all good. Let's check the translation table on R1. So I'll do a show IP NAT translations, and there, okay, I can see that the ICMP entry has timed out already. You'll see this in the real world as well, that connections time out pretty quickly from the NAT translation table. So let's do the ping again. So I'll ping that outside interface again from the inside. And now if I do a show IP NAT translations on R1, I see that the output has changed. That was the old one where the ping had actually timed out from the table. The new entry is here where I can see there's the ICMP entry. So there is the ping. So that was the ping. It went from the real IP address on the host, that's the inside local, which was 10.0.1.10, and that source address was NATed to 203.0.113.3. So that's how it will look to the host on the outside. The host on the outside is 203.0.113.20, and R1 is not doing any kind of translation for that outside host. So 203.0.113.20 shows up as both the outside local address and as the outside global address as well, because I'm doing one-way NAT here, I'm not doing two-way NAT. Also, we had that inbound web HTTP connection from the outside server going to the inside server, and that was going to port 80. So there, again, I can see that the inside local, the private address, is 10.0.1.10, and it was connecting on port 80. The public IP address that it was NATed from was 203.0.113.3, port 80. And the host on the outside that connected in is 203.0.113.20, and it was using source port 16282. Okay, so that's it. That's how we configure a static NAT entry and how we verify it with the show IP NAT translations command. See you in the next lecture where we'll do dynamic NAT. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.